Hello, my name is Umar Abdulganiyy, the team lead of SolarPeer 360. Together with my amazing teammate from the Federal University of Technology, MENA, we are addressing one of Africa's biggest challenges: access to clean, fair, and reliable electricity, directly supporting clean energy, education, and enterprise development. Here we are making that vision into reality.
Our solution is an AI-powered IoT-enabled dual system that tracks the sun for maximum energy capture and peer-to-peer sharing between tenants. With our platform, users can buy and sell electricity seamlessly, with every transaction being tracked in real time for transparency.
Support SDG 7, affordable and clean energy; SDG 11, sustainable cities and communities; SDG 13, climate action. We are empowering communities with up to 60% more energy efficiency, 25% less waste, and fair access. This is how we bring smarter, greener, and more equitable energy to Nigeria and beyond.
Presenting SolarPeer 360, a dual system approach to enhancing renewable energy capture and peer-to-peer distribution for residential communities in Nigeria. According to the Transmission Company of Nigeria, between February and December 2024, Nigeria's national grid collapsed 11 times, contributing to a total of 105 collapse in the past decade. These blackouts have pushed millions of Nigerians, including families and small business owners, to rely more on solar systems and generator, often without any real understanding of how much energy they use or how much it's costing them. We plan to revolutionize energy access by maximizing solar efficiency and promoting fair tech-driven energy sharing within residential communities. The problem we try to solve includes, firstly, unreliable national grid infrastructure, which is caused by frequent blackouts and poor power delivery from aging national grid. Secondly, inefficient solar energy, unfair energy distribution, which is as a result of unequal access to electricity leads to energy poverty. And lastly, lack of personalized guidance on cost-saving energy choices, less to inefficiency usage, and over-reliance on expensive energy costs. Our solutions are using solar tracking system, the renewable energy source, which is solar, and AI energy advisor, P2P sharing and management, and lastly, intrusion and alert system. The innovative technology used in our solution is firstly a smart solar tracking system which uses Arduino Uno and LDR sensors to read the sunlight intensity and adjust its solar panel with the movement of the sun. Also, ES32 based energy sharing, sensor based data monitoring, which is used by voltage and current sensors, ultrasonic intrusion detection, and lastly, AI powered consumption analysis. So these are a working video of our prototype which involves the solar tracking, and this is the solar panel that will be tracking the sunlight. So there are two LTR sensors. But when I cover it, this sensor here is getting more light. That's why it's now tilting to this or that side. And also for the main system, you can see I just restarted this. It's saying the reading of my voltage because we're in the night, it can't see any voltage, and my current also. Also the current ample of the solar tracking and the energy saved already. Because it's just plugged, it's currently in the 0 now, so it's increasing. So now moving down to my tenant one, it means any tenant that actually willing to buy energy from the main system of the owner. So this system will just be deployed inside the house of the tenant, and this is another system of the tenant too. So this is the reading of the voltage, and this is the reading of the current of the both tenants. So when I come to my design interface, I can see the reading of the 3 LDR is tracking the sunlight, the total energy saved because I just on my system, so the energy is 0.01, and the current voltage and reading. So if I want to on and off the system at the tenant one, I'll call it tenant one, and let's say tenant one have purchased some energy, so I'll just on the system from here and it's automatically on. So this is just the indicator, the white light, and if I off it, the white light will come off also. So also for the tenant too, if I just click on here, it will going to on the LED here, and also if I off it, the LED is going to go off. So this is just showing that the owner can actually control the system. Also, this sensor that here, the IR sensor, anytime a tenant gets close to this system, it's going to show an indication. So automatically send a WhatsApp message. So this is a WhatsApp message saying that obstacle detected by address at tenant one, meaning the system at tenant one has already seen someone get close to the system. And also tenant two also, anytime they try to tamper with the system, it's going to show also, which is another message saying that object detected by address at tenant 2. So this system is actually incorporating the whole address system, which is tracking sunlight, and the system that will be deployed in the owner system, which is controlling the overall solar tracking and the energy saving. And this will be deployed in tenant 1, anytime they purchase energy to control the energy, and also for tenant 2. So this can actually be replicated by having different tenants and be deployed in a real home. So this is the design interface for the solar system, and here you can see the current, the voltage, and the credit, and also here you can see the user analytics and the monthly comparison, and also the peak consumption times, and also the support and complaint, anytime you have a support or complaint with your system. So here you can actually enter the vending pin where you buy the energy and the owner of the system will be able to sell energy, meaning this is just an interface for the tenants. And also at the energy market where tenants can actually trade energy between themselves. So here's a list of all the tenants that actually buy the energy, and anytime you don't need the energy that you bought from the owner of the solar tracking system, you can just trade it with another user of the system. So and here you can be able to see all your history and everything where you've traded energy or before, and you can also file a complaint here also. This is the admin page. So it's showing bypass detected, which means when we did the hardware test, the tenant actually gets close to the system. So now you can see the total number of users, which users have actually showed interest in buying the energy, flagged users, which means users have actually tampered with the hardware, and active users, which means users that are currently active. So no user complaints. So the AI SolarPeer Advisor, which is a smart energy and cost planner, where each tenant and each user of the system will be able to compare different sources of electricity and be able to confirm that solar is actually the best option to use. So here you can choose from all the appliances you have in your house. You can use a PC desktop. I also choose maybe a water dispenser and probably add a rice cooker. So from here, I'll be able to choose all the number of it I'm using. So for PC, let me say I'm just using one. For water dispenser, I'm using two. So for rice cooker, I'm probably using 4 pieces. So also here you'll be able to choose how many of it are using per day. If it's 1 hour, 2 hours, or 3 hours. So below you'll be able to see the cost estimation by power source, and here you can activate the SolarPeer 360 smart plan, where you'll be able to see the optimization mode. Then how many users or tenants is actually using this feature. Then you choose the appliances for the first user, second user, and the third user, and you'll be able to see the backup source advisor, where you see avoid using generators for heaters and iron. And you can also be able to see the energy distribution, where you see that okay, all the appliances you have rice cooker actually take more of your energy, and PC is taking the lowest. So from here you'll be able to save a lot of money. The prototype specification that we developed, it includes using Arduino Uno ESP32 and all the sensor lists in this list with a total cost of 218,000 naira, and a picture beside it is the picture of the whole prototype built, which make it a low cost solution without an experiment, which we actually use to track the sunlight with a 15 to 20 degree angle between 9 a.m. to 6 p.m. So we actually used the solar power rating of 25 watt and 12 volts, and it was clearly shown that the solar tracking system, which moves dynamically, is 60.3% higher than the fixed solar tracking system. The social impact and outcomes. Firstly, it enhances energy and efficiency and access. Our system capture 30% increase in energy system and also reduces wastage by 25%. Secondly, localized innovation and scalable technology. We built it using a cost-effective locally available components. Thirdly, sustainable climate action model. We reduced fossil fuel reliance and promoting solar adoption, which means make our idea to support grid independence and cut carbon emissions significantly. And lastly, smart energy empowerment, which we give our users control over appliances decision and energy budget. The innovative team behind this project idea. Firstly, Umar Abdulganiyy, which is the team lead and the project manager, and in charge of the hardware and the IoT. Then we have Muhammad Abdulrahim, which is in charge of the MATLAB simulation and control specialist, and Solar, which designed the AI and machine learning model included in the system, and Officer Absalam, which is in charge of the business development and branding. Then Ridwan Nasiruddin, which is in charge of the web app development, and also Muhammad Ibrahim, the UI and UX designer of the idea.